Okay, we are good to go. Okay, so because we're doing through Zoom, okay, let's try to have some rules set. Okay, if you are really eager to ask any question or are not understanding, I want any of you or all of you to raise your hand through the Zoom. Do you know how to raise your hand in Zoom? Anybody who does not know how to do that? Do you know how to raise your hand?
We know.
Good. Arjuna has done it. Very good. Okay, Srinita has also done it. Thank you. Okay. Yes, please do that. Okay, then it will be easy for me to see, okay, who wants to. Thank you, Devishri. Otherwise, it will be difficult, right? I want, these are like a circle, right? So a circle because we all want to know, ask questions, understand together, okay, and try to see know how to take it forward. Okay, so let's start, okay, and see how we can take this along. Give me a second. Let me. Share my screen, stop sharing, and then I'll share it again. Cool. All of you are able to see my screen as well. Can you give a thumbs up? Or maybe a participant has said the speaking language to Dutch. And who is that? Somebody's playing with Zoom. Okay. Can I see a thumbs up or some kind of emoticon that you're able to see my screen? One of you, at least. Any of you are able to see my screen?
Yeah, I can see it.
Good, good. Okay, so let's start, okay, from where we left off last time. So last time I asked one question to both of you, the senior kids and as well as our middle school kids, okay, where we are asking how many ways can you distribute a certain number of things in a group. So let me have a concrete question so that you understand this. Say I have three kinds of fruits, three kinds, okay? So three kinds of fruits you have. This could be anything. Say apple, mango, and banana, okay? Now I give you, okay, an infinite number of apples, and this is very important. I give you infinite number of apples, lot of apples, okay? And lot of mangoes as well, okay? Infinite number of mangoes. An infinite number of bananas, right? And then I give you also, okay, 3 baskets. And I ask you that you have to pick up, okay, 5 fruits, okay, and distribute these 5 fruits, okay, in between the baskets. You're allowed to have, or not, you're allowed to have, yeah, first question is that you're allowed to have 0 fruit in a basket. And next time I tell you're not allowed to have 0 fruit in the basket. So here's the deal. If you think that the number of fruits that you have here, and this is the apple basket, okay, and then you have mangoes, okay, should go in the second basket, and banana should go in the third basket. This also I didn't let you know. So what you can do is that you are allowed to take 5 fruits, and this is how you can do. One of the examples I'm giving you, you would tell, okay, I would take 1 apple, okay, 2 mangoes, therefore 3 is gone, and 2. So basically 1 plus 2 plus 2 is equal to 5. Or you can tell 2 apples, 1 mango, and 1 banana. Oh, sorry, 2 bananas. That also is 5, right? So for me, it's 1, 2, and 2, right? 1, 2, 2. 1 apple, 2 mango, 2 banana, or 2 apple, 1 mango, 2 banana. These are 2 different sets, okay? So I'm asking you, how many ways can you distribute these 5 fruits of 3 kinds in 3 baskets? This is something I explained to the middle school kids. For the seniors school kids, this was assignment. Anyone who wants to go and volunteer and tell you how we can attack this problem. If you do not have a solution, I'm okay with that, but I want a algorithm. Okay, how do you want to approach this problem? So again, I'm telling you the 2 big things that you should see here. Okay, how is it different from any other problem that you have seen before? There are 3 kinds of fruits here: apple, mango, and banana. And the total number of fruits across the basket is being given. And I also tell you, you must have at least one, okay, at least one fruit in each of the basket. Means at least 1 apple, 1 mango, and 1 banana. 0 is not allowed. You cannot keep any basket empty.
Can't you put all the 5 fruits in like a row and put dividers in between them?
So let's go by that. So you're telling, okay, let's have 5. These are fruits, right? Okay, 5 fruits. And then what do we do?
You put dividers at like 2 dividers.
Sorry, I've given more than 5. My bad.
Yeah, you put 2 dividers at random spots.
At random spots. And what are the spots we're
Like
talking about?
between the sticks.
Between the sticks. Okay, so this is what the idea is coming up, and this is a good idea, that we are keeping we are assigning the fruits as stick or bars. Okay, and say this is one fruit, this is another fruit, this is another fruit, this is another fruit, and another fruit. Right now, what I'm telling is that, think of it, this is our star. Okay, that's why we call stars and bars also. So think of it like this. Okay, so now, right, how many we have to keep? How many walls do we need to separate it out? Do we need 3 walls or 2 walls, or how many walls do we need in this question?
2 walls. 2.
2 walls is enough, right? 2 walls is enough because look at it. If this is what we do, right, then we're essentially telling we have 1 apple followed by 1 mango and 3 banana. If somebody tells, no, I will not do like this. Okay, I will go like this. Okay, I will start here and start here. Essentially, the person is telling that, okay, I have 2 apples followed by 2 mangoes and 1 banana. Right? If somebody goes and tells, okay, fine, no, I will not do like this. Okay, I will tell, okay, this, right? And then this and this. So this person is telling, I have 3 apples and 1 mango and 1 banana. So we see that, okay, using this principle, we can line up the total number of fruits in this example, total number of elements that you're dealing with, okay, as sticks, okay, and whatever you are seeing as kinds of fruit, right, that we are representing as our asterisk or star, right? So stars and bars is a good analogy, right, to solve this kind of problem. Now the idea out here is that, okay, this problem reduces to how many ways can you choose 2 spots out of available spot. Is this one was 1 available spot and there's another available spot. So how many ways can you choose 2 spots out of 4 spots? That's what the problem reduces to. How many ways can I choose 2 spots out of 4 spots? Now, if I ask you what is the value of this, so you again do it from the basics, right? From the foundation. Okay, we'll not memorize anything. How many ways can I choose 2 spots out of 4 spots? Okay, fine. We have 4 spots. We can select, okay, one out of four people or 4 elements, and then I will select 3 elements. But then the point is that A and B being selected is same as B and A being selected, and therefore we'll divide it by 2. So we have 6. And the answer seems to be 6. Is there any kind of disagreement with the approach, or all of you are good with this? Good. Okay. Good. So if this is good, let's move forward, and now let's do the same example now, except for we have now k kinds of fruit. So we had 3 kinds of fruit last time, right? Now we are telling k kinds of fruits. K kinds means k is an integer. K is an integer, and I want to have n number of fruits. N number of fruits like this. We have k kinds of fruits. So remember the k baskets. This is the basket number 1 for fruit number 1, basket number 2, like that, dot, dot, dot. Okay. And then we have kth basket, right? We have k baskets out there. And then we start dropping fruits of a particular kind. Okay. So fruit number 1, okay, goes to basket number 1, fruit number 2 goes to basket number 2, and so on and so forth. And fruit number k goes to basket number k. Now what I ask you is that if the total number of fruits that I want at any given point of time is n, that means if I add the number of fruits out here, so say there are x1 number of fruits in basket number 1, x2 number of fruits in basket number 2, and xk number of fruit, right? X sub, we call it x sub k, x with a small k, right? X sub k, x sub k. Okay, sub means it's under. Okay, just a representation, mathematical representation, if you do not know. So we are telling that x1 plus x2 plus x3, okay, to xk must be equal to n. So I'm telling x1 plus x2. Remember, x1, x2 are all integers. They cannot be 0. Okay, plus x3, and we continue like that to xk is equal to n. Just think of it. Last time when I told you what was the example that I gave you in the last iteration, it was 3, right? So last time it was x1 plus x2 plus x3, and n value was 5. This is what you did last time. But this time I'm asking you, there are k baskets out there. Okay. And if I add all the fruit quantities in each basket, it will come to n. I'm asking you how many different ways can you do that, assuming x1, comma x2, comma x3. Okay, these are all greater than 0. In fact, I'll go a little bit extra until they belongs to. Okay, this sign the mathematicians use is called belongs to, and then I'm giving plus. This means z. Z means integer. Okay, whenever you see a big Z, that is integer. And if I give you plus, that means I'm telling it should be positive. 0 is not allowed. So I'm telling you all any positive integer. Okay, so x1, x2, x3, all of them should be positive integer. They cannot be 0. I'm asking you, how many ways can you solve this equation where x1 plus x2 plus x3 plus to xk is equal to n, okay, and x1, x2, x3 belongs to z plus. Do I have any raised hand at this point? Anybody wants to go for it? Srinita, go for it.
This is like what I have like so far. So based on the other one, we found that like there were 5 different there were like 3 wait, was it 3 in the first one or 5 basket?
5.
Oh yeah, okay. So yeah, we had 5 things in total. So I'm pretty sure this one we have k things in total. And so to apply this
doesn't have. Okay, let's try to understand again. Last time we had 3 kinds of fruit, right? And exactly 3 baskets. This time we have k kinds of fruit and k baskets. Total number of fruits, you can see it. Total number of fruits last time was 5. So if we add all the fruit quantities, okay, it will be 5. This time, if you add all the fruit quantities, it will come to n. Do you understand? We are dealing with k kinds of fruit. Okay, I want you to understand. So what we are doing. So think of it, there's a pile of fruits, okay? But there are k kinds of fruit. An infinite number of fruits are there. I ask you that you pick up fruits and put them, okay? But I want each and every basket to have at least one fruit. And if you add all the fruits across the basket, then the sum should be n. I'm asking you, how many ways can you do it?
Oh, okay.
Anyone else wants to go for this? This I explained in detail. No? Arjun wants to go for it because last time you told, I think you have a solution.
Wait, you mean me?
Yeah, because
There's two.
yeah. So look at the question is not
It's k minus 1, choose n minus 1.
or the other way around means
No, yeah, n minus 1, choose k minus 1.
n minus 1 choose k minus 1. And how do you approach that solution? Why do you go for that?
Well, because k minus 1 is like the amount of types, right? So, no, I mean, k is the amount of types. And n is the amount of bars.
Very good. Very good. Absolutely correct. Absolutely correct. Okay. So let's think of it this n, right? So think of it, this n is nothing but the bars. We have like this, no? N bars. Okay. So this is, I will tell the first bar, this is the second bar, this is the third bar, this is n minus 1th bar, and this is nth bar. Okay. I'm putting it, okay, nth bar. Now the question drills down to, what do you do now? Okay, we need k fruits, right? So, okay, fine. How many gaps are there? We need k, right? Think of it, okay? x1 plus x2 plus x3. How many plus you need? Think of this plus. If I tell you x1 plus x2, there are two kinds of fruit, you need one plus, right? If I tell x1 plus x2 plus x3 is equal to n, then you need two pluses when there are three kinds of fruit. So we are always saying the number of plus or number of star that you need, okay, that would be always one less than the number of kinds of fruit that you are dealing with. In this scenario, you are dealing with k kinds of fruit, and therefore you need only k minus 1 kinds of fruit, right? So we are dealing with that, and therefore, okay, I tell that, okay, fine, like this, I have to choose k minus 1 white space or spaces between the bars, and therefore the answer is n minus 1 c k minus. Because why n minus 1? Because if you have n bars, you have n minus 1 white spots, right? Out of that, you need k minus 1. So think of this example, right? x1 plus x2 plus x3 plus x4, right? So if I think of it, x1 is our bar, x2 as our bar, x3 as our bar, and x4 as our bar, right? So now the question is that not x4 as a bar, I'm telling you x4 the basket, okay, not the bar, okay? So in that x4 is the basket containing certain number of bars, okay? So then the question is that, okay, this is our wall. So think it like this. Think these two walls, okay, is one wall only. This is wall. Wall means these baskets are continuously there, okay? Think of it like a walls, okay? This is another way of looking into it, okay? So you have three walls, right? So you're telling, hey, where should I place the walls? Where should I place the walls means you are basically telling, I have n minus 1, and Devasri has raised the hand. I will take the question. N minus 1 is the total, okay, number of white spaces that you have. Out of that, I will fill them with k minus 1 star or plus sign, and that will solve my problem. Yeah, Devasri, go ahead. Go ahead. You have some question.
So with this method, how do we know that there will be no scenarios where there's like 0 objects in like one basket?
Yeah, that scenario will now come. Okay, so far my question was very specific, right? I told that 0 is not allowed. Now the next question will come, if 0 is allowed, how do you solve this problem? So far, I'm telling you that 0 is not allowed. That means every basket should have at least one element or one fruit in this example must be there that I asked in the question itself. Now, if I change the question and tell that, no, that is not good. I want some zeros, some can be 0. How do you solve this problem? Okay, that's a second question that I was about to ask, but now that you tell, okay, let's go for that. Yes, Srinita, go ahead.
I think we can add another like star to account for the place where we need to add a 0.
Another star?
Like, or another addition sign. Or not.
Think of it. No, I do not think another star would solve the problem. So let's take a very specific example, okay? Let's take a specific example and see, okay, what will change now. So we started our example with x1 plus x2 plus x3. Remember, 3 fruits with 5. And I told you that none of the baskets should have any, or should have at least one fruit. Now the question that Debsri is asking, and I posed this question to some of you, at least before, that what will happen in a scenario where we are now allowing 0 to be there. Previously, we were disallowing, right? We are not allowing this 0 element. Now we're allowing it. How should I now change my problem statement? Go ahead, Devishri.
Oh, wait, no, sorry. My question actually was, with the previous method, how are we like guaranteed that there's no situation with 0 objects being in the basket?
Yeah, you are guaranteeing, because look at this, okay? You are telling, what is this? This bar is, what does it signify in your analogy? This bar is telling you, okay, number of fruits, right? Nowhere I'm bringing 2 stars, okay, next to each other. Because if you bring, then it means there is nothing there in between. No way I'm doing it. That's why I'm telling you only between the white spaces. So let's take it another example, okay, so that I can show it to you. Think of it, there are 5 fruits, right? See this example, again, look at this, x1, x2, x3, and I'm telling x1, x2, x3 is greater than 0. That means there must be positive values. What I do is that, because there are 5 fruits that I need, think of it, that the 5 fruits, okay, have been laid down first of all. These are all fruits, okay? Because total has to be 5. Now I'm introducing the basket. Please do not think the basket is there, okay? Then we are going a little bit reverse way, okay? We are first telling we need total anyway 5, okay? Why don't you lay down the 5 fruits, okay? As if, or no, in a row, you are lying down 5 fruits, okay? Now we know that the walls of the walls are actually separating them out. So walls is nothing but our star, okay? This is, I'm telling, I'll put the star here. I'll put the star here, okay? And that is enough, because now you look at it, what has happened now. With this alignment, okay, you are ensuring, right, there are 1 in the apple basket, 2nd in the fruit number 2, which is mango, and sorry, 2 in the fruit mango, and 2 in the banana. Now coming to your question, right? How are you assuring that there is 0? 0 would have only have happened, okay, had I kept something like this. This could have been 0, because now whatever is to the left of this star, right, there's nothing there. Then it could have been a 0 element, but I'm disallowing it, right? This is not allowed. I'm telling only between the stars, sorry, between the bars. The stars have to be between the bars. In that way, you're ensuring, right, there is at least 1 bar on the left of the star. So you're basically preventing, with this analogy, any kind of 0 situation. This is the only situation can happen, because everywhere you have to place between that, at least one bar would be there, right? If not more. So you're ensuring that there are 1 or more fruits, okay, in the basket. Not sure?
No, okay, so, okay, yeah, all right, I got the visual representation. So how about the function, like the thing with the choose function? So mathematically, how did you represent that?
So that means you're essentially telling that, okay, I have the eligible spaces, right, which I can choose from, could be this spot, could be this spot, could be this spot, and could be this spot. So how many spots? 4 spots. And why did I tell 4? If you have 5 fruits, right, which is this 5 total, right, then it is always 1 less than that. So we are always telling there are 5 eligible spots where I can place my stars. So that means if it is n, if this is n, then it would be n minus 1, right? Always there'd be n minus 1 eligible spots. How many spots should I choose? That should be exactly 1 less than the number of kinds of fruits that I'm dealing with. In this scenario, there are 3, right? If you need 3, how many walls do you need? Walls means separators, right? You need 2 separators. That means if you have 3 fruits, you need 2 separators. If you have k number of fruits, then you need k minus 1 separators. That means the problem now reduces to how many ways can you choose k minus 1 elements out of n minus 1 elements. This is the choose function. And choose function, if you know it, it's great. Okay, that's why I wanted to show you. Okay, nck is nothing but factorial n, factorial k, n minus k. Anybody wants to volunteer and tell me once again? And this I'm very much fixated. I know that this is very repetitive for those who know it, but I want somebody to do it again and again and again before it goes into your head. Why nck is n factorial divided by k factorial n minus k factorial? Why is it true? This is just not a formula for me. For me, it's much more than that. I want you to tell me, okay, why it is true from the fundamentals. Anyone wants to volunteer, please? If you do not do that, then you are really disappointing me now, because this I've told enough times. Okay, I want an answer. Okay, someone go ahead and tell me why nck is equal to n factorial divided by k factorial divided by k factorial times n minus k factorial.
Can I say it?
Yeah, anyone? Please go ahead.
Okay. So the idea is that to choose n people out of k people, you start with n people, right? And imagine that there's chairs. So let's say you had 4 chairs and you need to choose 2 people. There's 4 options for the first chair, for the first person to sit in the chair. And there's 3 options for the next chair. So you get 12, right? So that's basically saying 4 factorial divided by 2 factorial, because you have to take away the other 2 chairs that were there before. But you're not done yet, because there's 2 factorial ways to arrange those 2 chairs, because if a person A sat on the first chair and a person B sat on the next chair, it's basically the same thing as B sitting on the first and A sitting on the next. It doesn't really matter. So that's why you have to do divided by k factorial.
Beautiful explanation. Thank you. Good job. Very good job. I want this explanation to come from everyone, okay? Fantastic explanation, okay? And this is the way you learn mathematics, okay? Not just a formula for me. I know exactly what's going on in that formula. So NCK, the way it was explained just now, is that I have to choose k persons out of n persons, right? How can I choose the first person? Any of these n persons, right? Now, moment I've chosen the first person, I can choose a second person from any of the n minus 1 persons that are left behind, isn't it? And I will continue like this, right? And continue like this to how many ways? I can do in 2 ways, okay? I can think it in 2 analogies, okay? Let's go with what Arjun told. Arjun, forget about the choosing part. His objective is that forget about choosing, right? Just let's arrange them. Let's arrange these n persons among themselves. Okay, if I do the arrangement, and this is his explanation, not mine, okay? So he's telling that, okay, it will be n factorial. Now, moment I've arranged them, okay? Now I tell, out of these arrangements of n factorial, okay, how many ways, okay, a certain group of people, which I'm telling k people, okay, they are always there in the first group of people whom I want to choose. So that means those group of people can arrange among themselves whom I'm choosing, okay, in k factorial ways. But if I choose them, then n minus k people are left behind. They can also arrange among themselves. And that is n minus k factorial. So this is the kind of theme that he is telling. The other way of thinking is that if I choose the first person, right, it could be n ways. And then the second person I can choose in n minus one ways. And the kth person I can choose in n minus k plus 1 ways. Right? This is the way I'm choosing, right? But these people, okay, when I'm choosing it like this, okay, this can be also written in another way by doing some kind of, we call algebraical manipulation, okay? For I showed to you in the class, okay, n minus k minus 1, n minus k minus 2, and I add this extra term. So see that what I've done, n minus k plus 1, n minus k minus 1, n minus k minus 2, like that to 3 to 1. That means, this extra term, okay, I'm adding, which is nothing but n minus k factorial. I just multiply and divide. No harm, right? If I have this entire term, okay, I multiply with a term called n minus k factorial and divide it by n minus k factorial. You can always multiply and divide by the same term. Nothing is going on. Nothing, it doesn't make any difference to the actual formula. So I can, let me repeat what I just now did. I can choose n first person in n ways, second person in n minus 1 ways, and the last person in n minus k plus 1 way. There's an ordering involved here. Ordering because I'm choosing the first person in n ways, right? Really doesn't matter. When you're choosing somebody, it doesn't matter whether you're choosing him first or last, right? Therefore, I can tell how many ways can this group of people arrange among themselves, okay? And that is k factorial ways. Now what I do is that, okay? Now what I do is that I adjust by multiplying with the n minus k factorial and dividing it by n minus k factorial. Nothing, no problem, because n minus k factorial is you are multiplying as well as dividing. But that brings an interesting thing, right? Then it becomes n times n minus 1 to n minus k plus 1, and then telling n minus k factorial. But then the numerator completely becomes n factorial itself, because n times n minus 1 times n minus k plus 1, and then multiplied by n minus k factorial is nothing but n factorial itself. So you have a numerator n factorial, denominator k factorial, and n minus k factorial at the bottom. Now, I personally is not very much inclined towards this explanation which I myself gave, right? This is more of a little bit of algebraic explanation. Some people like it. I myself do not like it. I like the way Arjun explained, okay? For me, this is very, very fantastic, okay? You arrange everything, okay? And then take the group, okay? Divide it by that number of arrangements, which is k factorial, okay? And then n minus k factorial left behind. They can also arrange among themselves in n minus k factorial ways. And therefore, the answer is n factorial divided by k factorial, n minus k factorial. This is a little bit algebraic. Algebraic because you are multiplying and dividing by this term, okay? That's why I'm telling it's algebraic, okay? But this is also easy to understand. More ways you understand the same thing, you become a better mathematician, okay? So it's up to you. Any question now? Anyone? Any question with this two approach? Why NCK is n factorial, k factorial, n minus k factorial? Go ahead, Devistri.
I'm sorry, but I didn't understand the part where you're dividing by n minus k factorial. So why does it really matter how the other people can arrange themselves even though they're not being chosen?
No. This part?
Yeah.
Okay. Let's break this, okay? And I'm going an extra length, okay, slowing down myself because it's good to see, okay? I can tell you even after several years doing or teaching this, okay, to multiple groups, multiple students, okay, I sometimes ask myself, okay, are we able to convince, okay, to the student, not to myself. I of course am convinced. Sometimes students are not convinced, okay. So let me show you with a very, very good example, okay, so that all of you are convinced, okay. So think of an example where we have A, B, C, D, and E, okay. You have been asked to choose 2 persons out of this group of 5 persons, right? 2 persons out of this 5 persons. So let's see if it is 5%, or maybe I'll make it a little bit, yeah, can make it 5, but it could be a little bit less, but that's fine. A, B, C, D, okay? So now think of it, what is going on here? Let's see how many of these, okay? There'd be, how many arrangements can you make with A, B, C, D? You can make 5 factorial ways, okay? And what is 5 factorial? What is 5 factorial?
120.
120.
120, right? Yes. So look at this, okay? So think of it, how many ways AB can be selected? We need 2 persons to be selected, right? Let's say AB has been selected. So if AB has been selected, okay, think of it, this arrangement, AB, okay, CDE, then CED, AB, ECD, AB, EDC, and AB, DEC, right? 6, right? 1, 2, 3. One more is there. AB, DCE, I think. Yeah. Do you agree? These are all the possibilities where AB comes in the beginning. I'm telling the first 2 persons would be chosen, okay? This is my chosen people, A and B. I've decided already, A and B would be chosen. Do you agree that all this arrangement, ABCD, ABECD, ABEDC, ABDC, and ABDCE are all the cases where AB has been selected in that order? That means A has been selected first, followed by B. But then there could be another series, right? BACD, BAECD, BAEDC, and BADEC, DEC, and BADCE. This is also possible, right? So now, if I ask you how many ways or how many of these cases A and B would be selected, you tell, uncle, that is very easy. Okay, let's do this thing. Let's arrange A, B, C, D among themselves, which is 5 factorial. Very good. Okay, now look at this. Okay, in every case where AB has been selected, okay, CD is arranging among themselves in 3 factorial ways. I've not put one case, I think, whatever case I've missed out, I do not know. CDE have missed out, I think, yeah. CDE, BA, CDE, right? So you have 6 cases, right? And why 6? Because C, E, and D can arrange among themselves in 3 factorial ways, right? So all these cases, we have AB being selected where C and E and D are arranging among themselves. So let's divide by these 3 factorial ways, okay? Because my interest is A and B selected, right? And therefore 3 factorial is at the bottom. But now the question is that, is AB selected, okay? Anything different from B is selected? AB selected, it looks like A has been selected first, followed by B. Here, B has been selected first, followed by A. But that doesn't make any difference, right? Because when you're selecting, who is selected first and who is coming second really doesn't matter, okay? Therefore, order does not matter. Therefore, A and AB can select among themselves or arrange among themselves in 2 factorial ways. That also is an overcounting, so we are dividing it. So we have a formula now. 5 factorial divided by 2 factorial divided by 3 factorial. Devisri?
Oh yeah, this makes a lot more sense. Thank you.
And this is not my explanation, okay? This is Arjun's explanation, by the way. Okay, I only formalize a little bit with alphabetical thing, okay? This is exactly what he told.
Oh, okay, my bad.
Yeah, no, good job. No, very good job. Okay, mine was a little bit algebraic I was talking about, but this explanation, okay, is a very, very logical explanation and makes complete sense why you are doing it. Okay, very good. Okay, now let's shift our gear, okay, to the other thing that I asked you. What will happen in a scenario where x1 plus x2 plus x3 is equal to, say, 5. But this time I'm asking you, or I'm telling you that each of the basket, right, can have 0 fruit. Last time I told you cannot have 0 fruit, and you came with the formula, right? N minus K C, N minus 1 C K minus 1, right? In this example, of course, it is 5 minus 1 C 3 minus 1, right? Because N is 5 here. This is equal to N, and K is 3, therefore 3 minus 1. So you have 4C2 was your answer. But now the question reduces to what will happen in a scenario where x1, x2, and x3 can be 0.
That's a different scenario, right, Uncle? Uncle, I just came. I was doing
okay,
some
yeah.
work. I was doing some work for another club, and then I accidentally like
Okay,
that's wrong.
that's fine. That's fine. So the question is that, okay, how many cases you can find out for x1, x2, or x3 can be 0, and yet x1 plus x2 plus x3 equal to 5? Anyone has an idea? Yeah, I'm not monitoring the chat, so if somebody is Manu is telling, okay. Go ahead. Yeah, Manu, means I told in the beginning of the class, if anybody wants to answer, please raise your hand, then I will ask you to go for it.
So typically you like Uncle, have you already talked about like the case without 0?
Yes, it has been talked about.
So you just add, like, you have to give like are you using n and k, or like what variables are you using?
No, I did not get it. Sorry.
Are you using n and k, Uncle, as your variables?
N and K in this example. No, let's talk about specific example. Then we'll go for this N and K. Right now, I'm talking of the scenario for x1 plus x2 plus x3 equal to 5. Very specific scenario, yeah. Where x1, x2, and x3 can be 0 or more, right? I'm asking how many ways can you do it, and I need a good explanation. Okay, why you are doing telling.
Okay. Well, generally, if you're doing with that, so I'll talk about, like, I'll just like recap the quick like when you can't have 0, that means you don't have to like take out, you don't have to distribute any extra balls, so you do all the positions. You can do you have 3 bars and 5 stars, or like, but when you're doing like, wait 1 second, Uncle, let me collect my thoughts.
Yeah, that's fine. And anyone wants to go for it other than Manu? I want a good explanation. Okay, just not throw an answer at me, please. Any thought that is going on in your mind? How do you use this fact, whatever you learned just now, this n-1 ck-1, or you can have a independent thought process for this particular scenario? No one? Okay, let me throw some ideas to you. I'll approach in 2 ways, okay? Again, we'll go with the bars only, okay? So last time, if you remember, in this particular scenario, it was 5, so you put 5, right? And then we're looking for some, the spaces between the bars, okay? And two stars, right? We put 2 stars in the 3 available spot. 3 available spot because this is available spot, this is available spot, and this is available spot, okay?
Uncle, I can like finish your explanation if you want.
Yeah, go ahead. Go ahead.
So you have three bars, and like you can put them anywhere. So first you draw 5 stars, or it can be anything, and then you have 3 bars. So that means in total you have 8 positions, or also 5 plus 3.
No,
That's
no, it is not 8 positions, okay? So think of it, one example could be something like this, right?
Uncle, I was about to cover that. Like it's only 7 positions. You take away 1 because um 1 bar is like, so like if you split up those 5 bars, like 2 bars can split up into 3 different like sections, but if you have 3 bars it splits up into 4, so you only do 2 bar you only have 2 bars for the scenario. So then you're supposed to, on the choose part, it's just it's like k-1 bars, in like you can in this specific example, since we have 3 for k, you do 2 bars, and on the other side of the choose you have it's you're supposed to, if you do for no cases with without 0, you have n minus k plus 1, but in this scenario you have to distribute k times 1 whenever there's no whenever it's like there's 0, the 0 can go into like a bucket. You have to like give back, or whenever you can't have 0, you have to give k into, or k times 1, and k being the number of bars, you have to like add k, and you take out wait 1 second.
Okay, let me formalize this thought process. It's a little bit jumbled up. Okay, so let me try to formalize it. Okay, so that we can all understand what's going on. So look at it. The previous example. Okay, we had to find these spaces between the bars, right? Because those are the available spots for the simple reason we wanted, right, deliberately 1 bar, okay, ahead of it, ahead of the starts, because we need at least 1, right? So it could be 1, it could be more, but at least 1. Therefore, we are always looking for the spots between the bars. But now we are telling 0 is allowed. So why not? Let's think of it. Okay, what could be the situation? One of the situation could be 0, 0, 5, right? Because 0 plus 0 plus 5 is equal to 5 indeed, right? So there are 2 zeros here, right? Or it could be 0 plus 5 plus 0 equal to 5. This is allowed, right? Or it could be 0 plus 4 plus 1 equal to 5. This is also good, right? So 0, 5, 0 is allowed. 0, 4, 1 is good. Or it could be 4, 1, 0, right? 4 plus 1 plus 0. That is also equal to 5. Now, if you see a pattern developing here, we have a situation where this plus, which was representing our star, right? And then it is followed by a 0. This is good. Okay, so I am saying that, okay, why not, okay, we introduce 2 virtual bars, which is not there, okay, which is the worst case scenario, right? These 2 bars, right, being brought forward, 2 extra bars. Why 2 extra bars? Let's see what will happen in a scenario like this. Okay, so if I want to represent 0, 0, 5, okay, see what is happening. Okay, so 0, 0, 5, right? So I'm telling 0, right, 0, 0. So look at it, 0, 0, right? Because nothing is there, right? 0, 0, and then 5, right? So I will put like this. Think of it. Sorry, my bad. 0, 0, right? Yeah. So think of it. I'm putting, okay, something, okay, the walls. Okay, sorry, my bad. I did give the wrong example to you. Think of this guy. Right? So what I'm trying to do is that I'm trying to pad up, okay? I'm trying to pad up my bars, okay, with extra 2 bars, which is 3 minus 1, right? There are 3 kinds of fruits. I'm adding 2 extra bars. That means I'm telling n was there, right, before, okay? So n plus k minus 1. So I'm telling n plus k minus 1, c k minus 1. Previously, it was n minus 1, c k minus 1. And I'm adding 2 bars. Now, sometimes this analogy, okay, it will be difficult to understand. I'll give you a better analogy, okay, and think of it what I'm doing now. So what I'll do now is x1 plus x2 plus x3 equal to 5, right? And you have been asked that, okay, x1, x2, and x3, okay, can be 0 or more. Last time I told you x1, x2, x3 has to be greater than 0. Now I'm telling, yeah, it can be greater than 0 or it could be equal to 0 also, right? This is what I'm telling you essentially. Okay, if this is the scenario, why don't we do this thing, okay? We define 3 variables, okay? y1, y2, and y3. We tell y1 is nothing but x1 plus 1. y2 is equal to x2 plus 1. And y3 is equal to x3 plus 1. Happy? So now your question becomes x1 plus x2 plus x3 equal to 5. This reduces to, okay, this reduces to x1 is equal to y1 minus 1 plus y2 minus 1 plus y3 minus 1, okay, is equal to 5. And can I tell, because x1, x2, and x3 can be 0 or more, then y1, y2, and y3 must be greater than 0 for sure. Is it a good way to think about it? Because y1 is nothing but x1 plus 1. And what is the minimum value of x1? 0, right? Then y1's minimum value has to be 1, right? 1 or more. So I'm telling y1, y2, y3 is greater than 0. So now we have an equation, y1 minus 1 plus y2 minus 1 plus y3 minus 1 is equal to 5. Or we have y1 plus y2 plus y3 minus 3 is equal to 5. Or we have y1 plus y2 plus y3 is equal to 8, right? 5 plus 3 equal to 8. Now we know how to solve this, right? For y1 plus y2 plus y3 is equal to 8 and y1, y2, y3 are greater than 0, not equal to 0. We already know that how to solve this because all of them are positive now. 0 not allowed. We know how to solve this. This is very simple. It is n minus 1, which is this one, n minus 1. Then here it is k minus 1. K is here, no, sorry, 3. 3 minus 1. So answer is 7C2. Any question on this approach? I introduce a variable, and this substitution approach, okay, is very, very common in mathematics, okay? You will see that it comes again and again, whether you do in calculus when you grow, okay, or even now, okay, you'll see that this comes. This is a mapping approach. Mapping means we are mapping x1 to y1, right? x2 to y2, x3 to y3. How we are mapping it? We are telling that y1 is nothing but x1 plus 1. y2 is x2 plus 1. y3 is x3 plus 1. That's all I'm doing. Why I'm doing it? I'm doing it because the approach was that greater than or equal to 0, there is a problem. But if I somehow can reduce the problem to another problem, which I already know how to solve, that makes my life very easy. So what I did was that I introduced 3 variables, y1, y2, and y3, such that y1 equal to x1 plus 1, y2 equal to x2 plus 1, and y3 is equal to x3 plus 1. We know that x1, x2, and x3 can be 0, okay, or more, right? That effectively means y1, which is x1 plus 1, must be 1 or more. But if it is 1 or more, we know how to solve the problem. Now the problem is something which is in our control. We know how to solve this. So now the equation becomes y1 plus y2 plus y3 is equal to 8. And we know how to solve the problem. If y1, y2, and y3 are not 0, that means they're 1 or more, then the answer is n minus 1 ck minus 1. And therefore it is 8 minus 1 c3 minus 1, which is 7c2. Any question with this approach? Any question? Do you all understand what happened just now? Too much? If there's no raised hand, then I've done a fantastic job. Then you have all understood what is going on here. Good?
I didn't understand it.
You didn't understand? Okay, which part you didn't understand?
I just don't understand the entire part.
You didn't understand the entire part? Okay, fine. Did you understand the previous part?
What?
Did you understand the previous part?
A little bit.
Little bit, then that's a problem. A little bit is not sufficient because I think by this time, that previous part, we're explaining that 3 times, okay? Have you thought about the problem at home before when you explain the class?
No.
That is the problem. Because if you do not think, they will not get it at all. Stars and bars, okay, is one of the key concepts in combinatorics, okay? It holds the foundation of combinatorics, but you have to think about it. If you don't think, okay, there is no magic to understanding it. I want you to think about it. If needed, take some 4 sticks with you or 4 pencils with you and try to think about the problem. If you do not get the problem, then you will not be able to move forward, okay? But if you understand that problem, then I can explain to you what is going on here. It's not very difficult to understand. Okay, but if you tell no, I do not understand how you solve the problem for x1, x2, x3, okay, all greater than 0, then I think no, we need to spend time. Of course, I'm ready to help you, but you have to think about it. That I cannot help you. Your thinking has to happen. Okay.
Okay.
Okay, but assuming that you know that, I will again explain to you so that all of you can see it, okay, in action. Okay, so this was my question. x1, x2, and x3, okay, such that x1 plus x2 plus x3 has to be 5, and each of these values or each of these variables, x1, x2, and x3 can be 0. What I tell is that, okay, because they can be 0, we have a problem in hand, we do not know how to solve it, we introduce another variable called y1, y2, and y3. Ensuring that this mapping, we call this mapping, right? y1 is nothing but x1 plus 1. So I'm telling that, okay, this x1 plus 1 is y1, x2 plus 1 is equal to y2, x3 plus 1 equal to y3. Now we know x1, x2, and x3 can be 0. But if any of them are 0, or all of them cannot be 0, that's fine. Okay. But if any of them is 0, okay, then y1 must be 1 or more. If it's 0, then this must be 1, right? If it is 1, then y1 is 2. So we can tell now the problem reduces to y1 plus y2 plus y3. But x1 plus x2 plus x3 equal to 5, right? Then what is y1 plus y2 plus y3? Let's see that. x1 plus x2 plus x3 is equal to 5. I told y1 is equal to x1 plus 1. In other words, I told x1 is equal to y1 minus 1. I told y2 is equal to x2 plus 1. In other words, I told x2 is equal to y2 minus 1. Then I told y3 is equal to x3 plus 1. In other words, I told x3 is equal to y3 minus 1. We also know x1 plus x2 plus x3 equal to 5. That was x1 plus x2 plus x3 equal to 5. That was given to you. That means
y1 plus y2 plus y3 now.
8.
So we have y1 minus 1 plus y2 minus 1 plus y3 minus 1 is equal to 5. Therefore, y1 plus y2 plus y3 is equal to 8. Right? Now this is a good problem to solve. Now we know what we have to do because we have already solved it before, right? And that's why I asked that if you do not understand that part, okay, the previous problem, then we have a situation. But this problem, I'm assuming that you have understood. If you understood, okay, that what we did there, that you have y1 plus y2 plus y3 equal to 8. In fact, I told in the previous scenario, y1 plus y2 plus y3 plus, like that, if we continue to yk is equal to n, we derive the formula that then it will become n minus 1 c k minus 1. In this scenario, it will be 8 minus 1 c k is there 3, right? This 3 minus 1, which is 7 c 2. Makes sense? Makes sense means assuming that you know this one, okay? Of course, if you do not fully not convinced, I understand still there is a gap, and I'll help you, okay? But try to think about it at home, okay, how we derived it. And if you still do not understand, let me know. I will again go through it, okay? But understanding this is fine, is important, not memorizing this.
Now.
Any question?
No, I understand it now.
Understand it. Very good, very good. Okay. Now the question is that I asked you the same question again. What would be the formation for x1 plus x2 plus x3 plus like that to xk is equal to n, okay? That means there are k kinds of fruits, okay? And that adds to n. But I'm telling you x1, x2, x3 to xk, they are 0 or more, not strictly greater than 0. Not strictly greater than 0. They can be 0 or more, okay? What would be the answer? Can you tell me in the form of as a function of n and k? Last time, remember, we already know this one, right? x1 plus x2 plus x3 equal to n. If I tell you x1, x2, x3 to xk is strictly greater than 0, then answer is n minus 1 ck minus 1. We already derived that. This one we know. But the problem now is that we have an extra, it can be equal also. I'm telling you, they can be 0. Each of them can be 0. Then what would be the formula? This one is known. This one we all know. Now, what would be the formula if it is greater than or equal to 0? We just now did it. Remember, I'm just trying to generalize it. Okay. We just now derived it. Now the question is that I'm trying to understand, okay, for k elements, not for 3 elements. What would be the answer? Anyone wants to go for a stab? I can write it for you. Anyone wants to try it, I'd be delighted, okay? Instead of me showing it to you. That's the way math circles should behave, okay? You should be trying it here.
N minus 1 ck minus 1.
For which one?
N minus 1 ck minus 1.
That's for cases with including 0, but for cases that it has to be greater, you have to distribute k. You have to distribute minimum 1 ball. Like if it's greater than 0, it has to be like there has to be at least 1 ball per like k bar, like k positions. So you have to add back k. So I think the formula would be for the generalized formula you can display is n plus k minus 1, choose k minus 1. And in cases without 0,
No, it's not coming. So look at it, okay? We have x1, it can be 0, right? Let's define, okay, exactly another k sets of variable. Think of it. Exactly the way
I think I have the answer. Is it n plus k minus 1, choose k minus 1?
Very good, very good. Wonderful job. This would be the answer. Correct. Look at it, why it is true, okay? Let's see it together, okay? And I think Arjuna has got it, okay? That's why he could tell. So y1 is equal to, say, x1 plus 1. Now, why I'm doing it? Because I do not know what would happen 0, but let's define a new variable y1 such that y1 is equal to x1 plus 1, y2 is equal to x2 plus 1, and yk is equal to xk plus 1. No harm with that, right? Xk plus 1, right? Not x2 plus 1, okay? x2 plus 1, xk plus 1, okay? Now, look at it. So that means x1 itself can be written as y1 minus 1. x2 can be written as y2 minus 1. And xk can be written as yk minus 1. And that is equal to n, right? That means y1 plus y2 to yk must be equal to how many ones? 1 minus 1 minus 1, 2. There are k ones, right? That means n plus k. But if it is n plus k, think of it, okay? This is n plus k, right? Now we know the formula, right? We know that the formula is n minus 1 ck minus 1 when this is n, right? But what is n now? N is now n plus k, right? Isn't it? Whatever is n, now it is replaced by n plus k. So in this formation, okay, in this formation, just replace the n with n plus k. So what will happen? N plus k minus 1, c k minus 1. And that's exactly what was told here. Have you got it? I went a little bit fast, but not so difficult to understand.
Yes.
Now
do you
these
put parentheses?
yeah, go ahead.
Do you put parentheses around the k minus 1, Uncle?
Parentheses under the k minus 1. This one?
Yeah, there.
It will not make any difference, right? You can do, but for what difference would it
Oh,
make?
yeah, doesn't, right.
See, I did nothing. I replaced this n with this n plus k because it was n here, right? This n, right? Here it is n plus k, right? N plus k is coming, right? So I'm putting n, I'm replacing with n plus k minus 1. See, k minus 1. That's it. Good. All of you are with me?
Yeah.
Now, these two formation, okay, I do not want any of you to forget, okay? Because if you forget this, okay, whatever would come next, okay, you'd be not be able to understand at all. So if required, okay, I would like you to go through this derivation again and again and again, okay? I cannot tell you how many times again I should tell. These are not difficult at all, unless you tell yourself that this is difficult, okay? Very simple things we're doing, okay, out here. But I do not want to remember the formula. Instead, okay, it should be so good, okay, you know where it came from. Do not tell, oh, and not choosing k elements out of, no, sorry, x1 plus x2 plus like that to xk is equal to n, and this is greater than equal to 0, then the formation is no n plus k minus 1, ck minus 1. Okay, I do not want you to memorize. Means if it gets into your head, that's a different story. But what is more important for me is that you understand how you derive the formula. That's mathematics. Giving you some bunch of formula is not my job, and it should not be a job for any mathematics tutor, okay, or teacher, okay? That's not mathematics. Mathematics is not a bunch of formula. Mathematics is all about logic, where it came from. Okay? And these are very, very simple thing. 3 or 4 lines, if you know use, then immediately you can derive the formula. You need not have a whole lot of things to derive this formula. Okay, good. Can I move forward? Any question on this? Anybody sleeping already? Okay. Okay, let's try to have some kind of quiz, okay? And let's try to sip the gear, and I will again come back. Box and is not going away anywhere, okay? So now I ask you another question, okay? And this question I asked actually to the senior kids, maybe not to our middle schoolers, okay? But this question is now again comes back to us. There are 4 different houses, okay? A, B, C, D. 4 letters have been sent to these 4 houses, okay? And these letters are being given as A1, B1, C1, and D1. In this example, A1 letter has come to A1 is post box, okay? B1's letter has come to B's post box, and letter C1 has come to C's post box, and D1 has come to D's post box. All very good, fantastic. That's how it should have happened. But in our problem, something strange is happening. None of these houses have got their letter which they were originally addressed to. In other words, A is getting a letter other than A1. B is getting a letter other than B1. C is getting a letter other than C1. And D is getting a letter other than D1. I'm asking you, how many ways is this possible? Have you all got the question? How many ways can you send 4 letters to 4 houses such that none of the houses are getting the letter which they're originally addressed to? That's my question. Any confusion with the question? You can raise your hand now, because you have to do something. And I want all of you to have some kind of notebook or something in front of you, because I'll be asking questions now. And I want you to do it with me. I would not give you the formula or something like that right away. The formula is complicated, but the question is that we can derive it with some minimum logic. Have you understood the question? Okay, so first thing is that how many total arrangements are possible? Forget about that constraint. Constraint means whatever I told you, that no, they cannot get the letter, okay? Think of it, what are the different possibilities that can happen? And how many possibilities are there? If I remove that constraint means that they are not receiving the letter, that's a constraint. For a minute, think that constraint is not there. Means constraint means that is as if I have not told you that. Okay, I'm asking you, how many ways can the postman distribute the letter to the 4 houses? Okay, what would be your answer? Shrinita, go ahead.
24.
Very good. And how did you get 24?
If we do 4 factorial, but like
Very
other
good.
than that, if you just think, okay.
Yeah, absolutely. 4 factorial. That's it. Okay, that tells itself. It's 24. Okay. Now the next question is that, can you all write in your notepad in front of you all the 24 cases? It should not take much time. I give you 2 minutes, all 24 cases. You can see how I'm writing it down, right? I want you to write like this only. All of you are done?
I'm done.
Done? Okay. Very good. Anyone not done? Can you raise your hand? Because we'll go to the next section. All done? Okay, if all of you are done, here's the question I'm asking you, okay? These arrangements that you did, I have not done all of them, of course. Now 18 is still there, and I can do the another one for D1, which I did not do. So C1 and D1. So C1 and D1. C1, D1, D1, C. C1, B1, B1 is replaced by C1, B1, and A1. C1 is replaced by B1. Sorry, C1, D1, C1. 3, 4, 1. So C1, T1, G1 becomes B1. Oh, no. C1, B1. Sorry, C1, D1 it becomes plus by C1. A1, B1. D1 is replaced by C1. B1, A1. And D1 is replaced by C1. So A1, B1. That's it. Okay. All of you have got it? Anyone not got the 24 cases? I'm not even asked you for any mathematics. I asked you something very easy, right? We are only ask you to arrange all the 24 cases that are possible. Can I explain the pi Tika? Yeah, I mean, so what can you can explain, but let me take you through a ride, okay? Because ride means now I want you to do step by step, okay, instead of jumping to the solutioning, okay? And that's the right way. All, if you're ready, can I see some hands raised? I think somebody's sleeping, okay, or some of you are sleeping. Maybe Sunday. Okay, thank you, good job. Okay, so here is what I am asking first, okay? All these cases, okay, are the possible arrangements through which I can deliver the letters to these 4 houses. But my question was different. How many ways can I deliver the letters such that no house will receive the letter to which they address to? So before I go to that question, okay, I ask another question. Can we start, okay, putting a cross mark, okay, like this, where at least one house, see, at least one house means could be one or more. I'm not telling exactly one house. Mark my words, what I'm talking, and this will be very interesting, okay? I'm telling as long as one of the houses, okay, have got the letter which they're addressed to, then it should not be a part of my solution. Because I ask you, how many cases are there in which none of the houses got the letter to which they're addressed to? That means even if one house has got the letter to which they're addressed to, we have a problem in hand. We should not be taking that particular case in our solutioning, right? So I'm asking you, can you start crossing, okay, all the cases where at least one house, so it's one or more. If it's more, no problem. But as long as one house is there in part of the job, okay, you start crossing it out and telling these houses, okay, should not be a part of our solution. So for example, in this case, the first row, if you look at my case, okay, your case will be a little bit different because you might not have done the way I have done, okay. I'm crossing it out because A has got A1, and therefore I am not even checking, okay, what happens to B, C, D, because that means at least one house has got the letter and therefore should not be a part. So, right? So all these cases, because A has got its no own letter, okay? So all these cases goes away, okay? Now, okay, now let's see all the cases where B should go away, okay? Well, right? Why is B? Why B is getting B's letter. So if I see anywhere B, I will, take away. There is, have I missed out? Yeah, there's no B here. Okay. Oh, there is there's no B. Yeah, see here, this case will go away because B is getting B's letter, right? And this will also go away. Okay. And then C is getting C's letter. So wherever they C. So yeah, see here, this going away. This also goes away because this also goes away. This goes away. The fiber C is no B is going away and C is going away. I'm taking them out, okay? And then maybe I'll do what I'll do is that I'll put a double cross so that I understand why I'm taking the B away. Okay. So A, as we saw that, okay, B, okay, I'm putting double cross, okay, double cross, okay. Oh no, this is not B, right? What is the problem? Oh, this is C's case. C, yeah, C. And this is B. This is B. This is B. Is also B.
Actually, I might be able to explain it.
You can explain it. I'd be delighted to. And
Could I try?
give me a second, but I want to go step by step, okay? I do not want to jump any step and give some explanation which is a little bit
Yeah.
hazy. Okay?
Yeah, it's okay, Uncle. That makes sense.
Yeah. So do you want to screen share if you can do, or it could be difficult for you. Do you want to do it on my screen and I can mark it for you?
Yeah, Uncle. I mean, I can try explaining verbally too.
Okay, go ahead.
So first we do first there's 4 houses, right? So out of so the houses can arrange themselves 4 factorial ways. That's a given 4 times 3 times 2 times 1. So and then that's how many ways they can arrange themselves, but we're not looking for how many ways they can arrange themselves. We're looking for how many ways can 4 letters not go to each house. So first we can do how many ways can so how many ways can we set that one house or one house gets the letter they wanted or that they were designated to get. So that's what 4 choose one way, right? For how many ways can one house get the letter that they wanted? Is that good, right, Uncle?
You are telling, I'm not even explaining. I thought
Yeah.
you.
So no, I'm just that's correct, right, Uncle? 4 choose one way. You're choosing one house. There's 4 ways you can choose one house to get the letter they designated, and then you have 3 letters that are set to be mailed to the other 3 houses. How many ways can that be rearranged? That's 3 factorial ways. So you're subtracting all that, but then you're missing the cases in which 2 houses get the correct designated letter.
No.
How many ways?
No. I do not agree with that argument. Why are you missing out? That's the part. Where I want to go slow. Okay.
Okay.
That part I do not agree. Okay. And I last time when I was talking to you, okay, you means to all the kids, okay, so the high school kids. I wanted you to think about it, but I've still not got the answer. Okay, which I was looking for. So let's go a little bit slow. Okay. So if you look at it, are all of you getting what I'm doing? See, initially, I told how many arrangements are possible. That is 4 factorial, which is 24 ways. And we wrote down all the 24 cases. Now we're telling that find out all the cases where at least one has got the letter to which they're supposed to get. Let's start with the first person, right? A. Let's cross out all the cases where A has got the letter to which it was addressed to. Okay, that means A has got A1. Okay, and therefore I cross down all my A addressed to A1 cases. Do you all agree? Are all of you seeing that? All the cross, okay? single cross that we are seeing out here, okay, they are the cases where A has got A's letter. That means A has got A1. Because if A has got A1, then it is not a part of my solution, right? None of them should get their letters to which they are addressed to. Any confusion with the question? If it's total silence, then the only thing is that either you're understanding fully or you're not understanding anything. And I cannot read your mind, okay? At least I do not
Understand.
I understand.
Okay, good. Okay, at least some response if I get, I understand it's going on. Good. Okay, fantastic. Okay. So now the question is that, okay, I cross out these cases where A has got A1, right? That means it has got the letter and therefore they are not a part of our solution because we do not want anybody to get their own letter, okay? Now I tell, okay, fine. How many cases B is getting its own letter? That means B has got B1. And therefore, I started, see, this case, okay, the one that I'm highlighting, okay? I'm putting it like a little bit differently, double cross, okay? B has got B1. This case also, B has got B1. Okay, this case, and then this case, B has got B1, right? And this case, B has got B1, right? Is there anything case I'm missing? Maybe yes. This case also B has got B1, but we have already crossed it, but this also falls under category. Do you agree? The one that I'm saying at the top, right? This case also B has got B1. And of course, A has got also A1, right? And then, so how many cases we are seeing A has got A1? Of course, 6 cases, right?
Yeah, I forgot to talk about like distinguishability.
What is that, Manu?
I forgot to talk about like distinguishable versus indistinguishable.
How is it relevant in this question?
Well, like actually no, never mind. It's not. I just forgot. But the ordering is, Uncle, like what you're mentioning.
No. Ordering also important, Manu. So let's focus on whatever you're doing, okay? And then you'll see that what the puzzle is becoming so critical and how we can solve it, okay? So we see that, okay? Look at the first row, okay? First row, I have given a single cross because A has got A1, right? I have given a double cross because B has also got B1. Second row, A has got A1 as well as B has got B1. Therefore, it has got a single cross and the double cross with a circle because B has also got B1. In this case, okay, I've only given a single cross because A has got A1, but B has not got its B1. Therefore, I'm not given it, okay? And this is the way I continue, okay? So look at this. Single cross, we have 1, this one that I'm showing you, this one, 3, 4, 5. What is that? Did I miss some extra? It should be 6 exactly, right? Oh, no, maybe 1, 2, 3, 4. Oh, my bad. Yeah. Sorry. Yeah. It should be 1, 2, 3, 4, 5, 6. Exactly 6, right? 1, 2. Why is more? Oh, maybe I put some wrong place or what? 1, 2, 3, 4, 5, 6. Yeah, 6 only. So you see these 6 cases, right? These 6 cases where all has A has got. Now let's see B's cases where B has got B1. So this row, B has got B1, right? These cases also B has got B1. This case B has B has got B1. Sorry, this one, right? One that I'm circling. And this case also B has got B1. So it's true for this one. B has got B1 and B has got B1. How many cases? Again, 6. Do you all agree? But, okay, there are 2 cases you saw where A has got A1 and B has got B1. Both has happened. These are top 2 rows, right? So hold that thought for a moment, okay? Now let's go for the C's cases, okay? How many cases C has got C1? Now C has got C1. I'll put that as a single circle, okay? Now C has got C1 in this scenario. This also. This one. Then this one. And I'll erase this out. C has got C1 in these cases, okay? And then also C has got C1 in this scenario also. And then we have coming down here. C has got C1. And then here also, last one. And one more case. 1, 2, 3, 4. Yeah, I've got 6. Okay. So C has got C1 in all the 6 cases. But remember, there are a few cases we are seeing where okay, for example, the top one you see that where C has got C1, right? A has got A1, B has got B1, okay, and D has got D1. Okay, so a lot of overlap is happening. In this scenario, you see that C has got C1, right? And here, as you see the number, the 3, I think, which is for D. Okay, D has got D1 also is there. So you see some overlaps happening. So now I ask you the first question, okay? If I ask you, how many of these cases, okay, where at least one has got the letter to which they're delivered, you can give me a quick answer telling that, uncle, if one has got, right, one has got the letter to which delivered, okay, rest 3, okay, can arrange among themselves in 3 factorial, that is 6 ways. Do we agree? Are all of you getting it? If at least one has got the letter to which they are addressed to, how many are left behind? Rest 3. We do not know whether they have got the letter or not got the letter, but they can arrange among themselves in
3 factorial ways.
3 factorial ways. And that's true, right? For example, if B has got the B1, I do not know what has happened to A or C, right? So think of it. B has got the B1, which is all these cases, right? But B has got B1, B has got B1, then B has got B1, B has got B1, B has got B1, B has got B1, right? All these cases, what is happening is that B has got B1 is the information that I've given to you, but I've not told you what has happened to A, right? To the C and D, these 3 houses. What is happening to them? Maybe they have got it, maybe they have not got it, who knows? So you tell, okay, fine, that's fine. Then B has got the B1, let's fix it, okay? We call fixing it because we know that information, you have told me. Let the other 3 arrange among themselves in 3 factorial, that is 6 ways. That means with B being fixed, B being getting the letter to which is supposed to get, okay, we have 6 ways of arranging the others. Similarly, if A is fixed, that means A has got its own letter, B, C, and D can arrange among themselves in 6 ways. And so is true for C and D. So that means 6 times 4 is 24 ways. So your answer could be, uncle, it is 24 ways in which at least one of them has got the letter to which they are delivered. And then I claim that answer is wrong. Definitely wrong, because if that is true, then you told total number of arrangements was 24. Okay. Now you are telling that every single time, okay, I'm fixing A or B or C or D, there are 6 ways of arranging the others. That means 6 times 4 is 24. So you're subtracting away the 24. Your answer seems to be 0 now. That doesn't make sense. You're telling 24 is the total arrangement, and you're telling, well, 24 is the number of ways in which at least one of them is getting the letter to which they are supposed to go. That really doesn't make any sense. So there is genuine flaw in my statement. Can somebody tell me what is the flaw that I'm making? Why is the overcounting? I'm telling it cannot be 24 ways in which, okay, at least one of the houses are getting the letter to which they're letter that they're supposed to get. That answer cannot be 24. It should be something less than 24. But I'm giving you an explanation. Why is the problem? If you can answer that question, I'm already giving you the hint enough. You should see at what I'm doing, okay? I'm telling that if you fix A, that means A has got its own letter, then the B, C, and D can arrange among themselves, okay, in 6 ways. Similarly, if you fix B, right, then A, if you fix B means for B is getting the letter to which is supposed to get, then A, C, and D can arrange among themselves in 6 ways. If you fix C, then A, B, and D can arrange among themselves in 6 ways. If you fix D, then A, B, and C can arrange among themselves in 6 ways. Therefore, 6 plus 6 plus 6 plus 6, which is 24 ways, are cases where A, B, C, and D have at least got their own letter delivered, okay? That gives us 24, and 24 is the total number of cases. It looks like no, we have no, everything is going off. So where is the mistake in the logic that I'm stating to you? I'm doing a deliberate mistake, and I want you to tell me what is the wrong in my argument. What kind of mistake I'm making?
I think it's because you're rearranging all the letters every single time, right?
Why shouldn't I rearrange? I should rearrange, right? Because if I got the letter, one of the letter, I tell you, then I can rearrange it.
No, but if you rearrange it, then there's a chance that one of those letters actually ends up going to the right spot.
Very good. Absolutely wonderful. That's what exactly I wanted to hear. Okay. So look at this problem that with this argument, and that's what right argument. If A has got the letter, okay, we just now told B, C, and D and arrange itself. But doesn't it also include a case where B has got his own letter? Aren't you overcounting that way? So you removed it, right, from your list. But then when you're counting for B, again you are coming to that row and you are again removing it. Why should you remove it? It's already removed from your list. You're again coming to B and telling, hey, now look at this case where B is getting its own letter, okay, and therefore it should be removed. But the problem point is that you removed it already when you were thinking about A. A got his own letter, therefore it should be removed. You removed it already. And when you thought about B's case, you again removing it. That's doubly, you are removing something which is now already removed. That means you are removing more than what you were supposed to remove. Are you getting the point? This is the key argument, okay, in the whole thing, because we do not understand this overcounting problem, okay? You would not understand the derangement problem. It's not easy to see that, okay? That's why I see that there are cases, right, where there is, no, here in this scenario, for example, C has got his own letter, okay, and therefore it has removed. But here, I'm also telling A has got, A or B, whatever be the case, okay, has got his own letter. It has also been removed. That's no good. You are removing the same thing not twice. That means you are removing it more than the times they are supposed to get removed, right, from your solutioning. So it cannot be 24. It should be something less than 24. Are you all getting my point? Or no?
I get it.
Yeah.
I understand it.
You don't understand it?
No, I do understand it.
You understand it? Wonderful, wonderful. If I will to make you understand, I'm so proud, okay? Because this is not an easy one to think. But then if you've understood it, now I give you a follow-up question, okay? So now the question is that, how do I compensate for it? So we understand that there are cases where you're removing more than what you are supposed to do, but then we have to compensate it, right? That means we are removing more than what we are supposed to do. In the process, I want to, return them back. Now we think, okay, fine. Hey, you talked about one, right? At least one.
You're including the houses that get 3 as well.
Now we'll go for 2 first, okay? Not 3 so quickly. Let's go for 2.
I thought you did 2, Uncle.
No, I did not do 2.
Oh, sorry.
Okay. Now let's ask ourselves this question. How many of the cases are there where at least 2 of the houses have got the letter to which they're supposed to do? And we can pick these 2. It could be A or B. It could be B or C. It could be A or D. It could be D or C. So like how many cases are there where 2 of the houses are getting the letter to which they're supposed to get, okay? So, and that answer is very simple, right? Let's pick these 2 houses. Out of 4 houses, how can you pick 2 houses? Out of 4 houses, how many ways can you select 2 houses?
4 choose 2.
4 choose 2, absolutely correct. And what is that? What is 4 choose 2?
12.
6.
6.
6. It is not 12. 4, again, ask yourself, how many ways can I select the first person? 4 ways. How many ways can I select the second person? 3 ways. But choosing the first person followed by the second person is same as choosing the second person followed by the first person. Therefore, you divide it by 2 factorial, right? The way they can arrange among themselves. We divide it by that. So it will be 4 times 3 divided by 2 factorial, which is nothing but 6. Right? You always should not rely on formula, okay? Think about it. Why 4 choose 2 is 6. Okay, but again, assuming that you know or you are really convinced about it, so we know that there are 6 ways we can choose these 2 houses out of 4 houses, and they have got the letter to which they are supposed to get. We are left with another 2 houses, and they can arrange among themselves in 2 factorial ways, right? So that has to be given back. But then there is the problem again. If you give it back to the fold, okay, you're giving more, because there would be some cases where 3 houses have got their own letter. You told at least 2, right? At least 2 also means 3, right? When you're giving it back, okay, you are also including some cases where all the 3 houses have got their own letter, and that's no good, because now you're giving more than what you're supposed to do. See, look at it, okay, how it is same as whatever you learned in the pi. Pi, you are excluding and including. Here also exactly you are doing that. You first of all told how many ways can I arrange among themselves. Then you took away all the cases where there is at least 1 houses, okay, have got their own letter. But when you took it away, you actually took more than what you are supposed to do, because you are also thinking of all those cases where 2 or 3 or 4, okay, they're also being there, right? So you tell, okay, fine, because I have taken away more than I'm supposed to do, or I'm excluding more than I'm supposed to do, let me bring it back. And how much am I bringing it back? All those cases where 2 houses have got the letter to which they're supposed to go. You bring it back. But when you bring it back, you saw that you are now bringing it more than you are supposed to bring, because those also would include the cases where 3 houses have got their letter. So you again have to subtract. And that's exactly what pi does, right? So let's formalize it, okay? Formalize means let me show you what I want to do. So we started with this fact, 4 factorial. Then you tell, okay, how many ways can I choose the cases, okay, where at least 1 house gets the letter they are supposed to get their own letters, and that house can be chosen in 4 choose 1 way, right? If 4 choose 1 way have got the letter, then the rest of the houses can arrange among themselves in 3 factorial ways. But then you thought that, okay, fine, this is overcounting, you're removing too much, right? And of course, it doesn't make sense, because this is 24 and this is also 24. If you calculate, right? 4 choose 1 is 4 and 3 factorial is 6. 4 times 6 is 24. It doesn't make sense. Why should be 0? And you understand, okay, why it is becoming 0? Because you are overcounting, no? You're reducing too much. So now you tell, okay, fine. No. There are some cases where the 2 houses are getting their own letter. So let me add that back. 4 choose 2. And then there are 2 houses left, which I'm arranging among themselves. Now, if you do that, you are giving more, because there would be cases where 3 houses are also getting their own letter. So you tell, I will not subtract it. Now you tell, how many ways can I choose these 3 houses? 4 choose 3. Okay. And how many houses left behind? 1 factorial. Okay. And then the final piece, which is 4 choose 4, which is 0 factorial. Means we do not actually do that. Okay. This is not needed, because that case does not even arise, because 1 means no, you are done. So answer is no, this one. 4 factorial minus 4 choose 1, 3 factorial, plus 4 choose 2, 2 factorial, minus 4 choose 3, 1 factorial. All of you are convinced this is the answer? No? It's good to tell that, okay, I'm not understood. Okay, I don't understand. No, whatever I'm telling you, okay, these are difficult problem by any standard. Okay, it's not easy one. But if you can convince yourself, okay, almost any question now in combinatorics would be in your fingertip. You can take a day or 2. I do not care much.
Uncle, why don't you add the 1 at the end?
Because when you're doing 4 choose 3, right? Then you have 1 houses left, right? If you have 3 houses out of 4 houses, 3 houses have got the letter to which they are delivered, what will be the fate of the last one?
Only one. Yeah, it doesn't really change.
There's nothing now left, right? To add, to subtract or add.
Yeah.
Got it? No? And if you're not convinced, I want you to actually write it down and see whether it's manually, whatever you're doing, okay, it's really adding up to the value that you want, okay? This is very, very simple, okay? Again, I'm telling you, it's what I'm doing essentially is a Venn diagram. You perhaps didn't notice it, okay, when I was doing it, okay? Of course, four Venn diagram is a little bit difficult to draw for me, okay? 3 could have been easy, right? I told you, right, 4 cannot be drawn, okay, for a good reason. It's not very easy to draw 4, okay, Venn diagram. It does not go through all the circles. But if you really think of it, what happened was that, okay, I excluded the cases, okay, and this overlap, okay, but 2 houses are getting, okay, that was getting reduced too much, okay, and therefore I gave it back to the fold, and that's what happened here. I subtracted too much and therefore gave all the houses or all the cases where 2 houses were getting their own letter. I added it back. When I added it back, then 3 houses getting their own letter, okay, that have to be brought, subtracted out. In other words, if there are n houses, forget about 4, okay, then this is how it begins, okay. N factorial is the way, all possibilities. Then I'm telling NC1, okay, n minus 1 factorial, right? Then plus NC2, okay, n minus 2 factorial, right? Minus NC3, n minus 3 factorial, plus NC4, n minus 4 factorial. And I continue like that before I exhaust out of all the options. Are you getting it? What is happening? This is exactly pi. All the possibilities which are, which is leading to my double counting. Okay. So basically, reduce at least 1 cases, but at least 1 also includes at least 2. Okay. Therefore, give it back. At least 2 includes at least 3. Therefore, again, take it away. At least 3 includes at least 4. Give it back, and continuing like that. Inclusion and exclusion, and therefore it is pi. You're including with all these plus signs, excluding with your E for exclusion because you're overcounting. Not convinced? Who are not convinced? I want to see the raised hands, and I would not be really depressed or frustrated if you raise your hands, because this is not an easy one to understand. I fully understand that. You have not understood Devashree at all, or got
Okay,
a
so I actually understood everything except this one part. So for 4 choose 2, why are we multiplying by 2 factorial?
What is that? If you have chosen 2 houses, right, where the letter has to be delivered, how many houses are left behind?
Right. Oh yeah, 2.
So those
Oh.
are 2, and I can, yeah, because think of it this scenario, right?
Yeah.
See, A and B here, first scenario, for example, both A has got A1, B has got B1. Now C and D, either it could be D1, C1 or C1, D1.
Okay.
Right?
Yeah.
Similarly, say C has got D1s and D has got D1s, and there could be a scenario. Yeah, exactly. C has got one, D1 got, either it would be B1, A1, or it could be A1, B1, right? We must have somewhere another case. Okay. C1.
Right.
Yeah, this one. But look at this, okay? Now we are not reducing it too much, right? Again, we are giving it back because you are doubly reducing, okay? You should be reducing only once, but you reduce too much, right? Or you are giving it back, but in giving it back twice. So we are again reducing it because you also include the all 3 cases, right? So you are giving it back and again, bringing it okay, back to your fold, okay? That's the principle of pi, okay? I'll tell you as a student what I used to do, okay? Maybe it will help, okay? When this was explained to us and we did not have the luxury of of these 2-hour sessions that we have, it is all being taught in some classrooms, okay, or wherever we used to go, okay? I do not remember also first time where I heard it, okay? But this is my thought. I'm pretty sure I used to be in a hostel that time because I was not in this age, okay, I got introduced to this. I maybe was in the 10th grade or 11th grade by that time. Okay? I used to come back in the hostel, and some of the kids who are a little bit sharp or they thought they have understood, okay, we should talk. And when you talk, okay, some of these kids who thought that they have understood, okay, they're now telling, no, I'm not understanding now. And that's perfectly fine. So again, we go back to the drawing board, okay? Drawing board means I write down all the cases, maybe with a 4 or 3 or 2 or 2 is too less, okay? Maybe 4 or 5, okay, depending on 5 would be too much, right? You understand that 5 would be 120 cases, okay? Too many things you have to write. 4 would be the perfect one, or maybe 3 also is fine, okay? I write down the cases and see, okay, fine, what is going on here, okay? I have all the arrangements. Then I wrote at least one, and then I was crossing out the way I started, okay? And then, well, I just now crossed it. Why I'm crossing it again? That means I'm crossing too much. Then I have to give it back. So I try to convince myself, is it really happening the way it should happen? Or it's just a formula? Now, there are some kids, okay, in our time who would not go do all this, okay? Their objective was pretty simple. If it comes in examination, I'll remember the last formula, whatever I wrote down. The problem that you'll have is that you might be able to memorize this formula, but when in the examination they ask you the question, you'll not be able to do it at all, because they would be tweaking the question in such a way that it would be of no use. And I will be showing you some problem statement, okay, for exactly on this principle, but not directly using the formula. But if you understand the principle, you can easily do it. So you have to convince yourself why I am subtracting and why I'm giving it back. Means it's okay to tell that, okay, I've not understood, okay? So I want to get a sense. Let's take a kind of vote, okay? How many of you have understood 100%, whatever I talked about? Raise your hands. Okay. How many of you understood maybe not the full thing? Okay, a lot of hands I'm seeing actually, 6. Okay, whoever is now raising the hand is 100% or 50%? I was about to tell 50%, but I'm seeing a lot of
50.
Huh? What is that? 80%?
50.
50? Okay. 50% is good actually, you know. I'm actually happy if you tell 50%. But now my question is that how to convert the 50% to 100%, right? That we have to do. We cannot be satisfied with 50%. But if in the first run, right, today is the first time you're seeing this, right? So if first time you are telling 50%, I'm immensely proud. At least you have got a sense, right? You may not be understanding full, but you are getting a sense why I'm doing it, okay? What I want to do, you to do, okay? If not today, okay, tomorrow, in the evening time, I want you to write the cases, okay? And then start crossing the way I was doing it, okay? And see whether it is matching your expectation or not. If it does not match your expectation, you do not understand, okay, why you are adding or why you are subtracting, you get back and let me know, okay? And I'll be able to clear your doubt. But if you do not do that, okay, and then uncle will do some magic and I'll understand that that is not going to happen. It has never happened with anyone, okay? This principle, this is called derangement, okay? This is being taught in some cases, some universities, they teach it, okay? But the point is that whatever I'm teaching you just because, no, not because of anything else, these are being asked in the competitive examination. AMC asks it, okay? It is being asked in math counts. Unfortunately, fortunately, those who have, it is a lot of books, okay? They just give you the formula without telling where they got it, okay? That is even more worse than what, no, not giving it. Because if I give you some formula and you have no idea where it came from, you're like, okay, man, what is happening? Why this complex formula is somebody is telling it to me? But honestly, it's not complex. It's simple pi principle at work. So I want you to do it once, okay? And then get back to me. Is that something we all can do? It's 8:58. I do not want to stretch it further, but I want a yes. Yes?
Yes.
Good. Very good.
Yeah.
Okay, fine. So it's 8:58. I will not stretch it. Okay, it's Sunday evening. Okay, you have your schools tomorrow. Okay. Just something I have observed, okay, in Canvas. I'm seeing most of you are not making full attempt. I'm giving the assignment and then I see that, okay, there is a very casual attempt, okay, in solving the problem. I thought of discussing something from the Canvas. is it something I can expect from all of you? You go to the Canvas, okay, and I'll open up some of the assignments that you've already submitted or what the deadline is already over, okay? I want you to go through the assignments, not the quiz, okay? Quiz is fine, okay? Quiz would continue, we'll open up, close, etc. Assignments, I want you to make a real attempt. And especially if there's a discussion out there, discussion forum, okay? I want you to collaborate there. Collaborate, mathematics becomes good when you show your argument. It might be a wrong argument, that's fine. Even this is the way I was thinking about this problem. And that's how we learn mathematics. Mathematics is not about one person telling, okay, this is the right answer. There's nothing right or wrong. Mathematics is all about challenging, right? Even I am talking, okay? You have to challenge me, right? Telling me, uncle, I'm not convinced what you are telling, okay? And that's the right way of doing mathematics, right? So I want you to write it down. Whatever thought is coming, just like you submit an essay, write it down in those discussion forum. And next time when we are meeting, okay, I want to see that we have a lot of inputs there. I am seeing we are not just spending maybe 5, 10, maybe 15 minutes, not more than that. I can see from that argument, okay? Some of you, okay, are doing a lot of work. I see that also. Who are going an extra thing, okay? They are putting something in the paper, okay, drawing something, and then ultimately uploading it, okay? That's fantastic. And that's what I want, okay? I want you to explain whatever is coming to your mind so that I can read your mind. I understand how you're thinking, not just give me a solutioning. That's one thing. Another thing I'm saying, okay, some of you, okay, what you are doing is that you are not convinced about what you are writing. That means you yourself know that, okay, that is not correct. And yet you are giving it. That for me is pretty disappointing. Why disappointing? You are not convinced. Why do you think I would be convinced? Mathematics, okay, two things you have to do. You have to give respect to the problem, okay? Not to me, I'm telling, do not respect me, or that's not important, okay? Important is that you have to respect to the problem. If I'm giving you a problem, remember that problem is challenging. I'm not giving an easy problem. And give the lot of respect to the problem. That means think the problem, okay, has been given to me, and it is my job to read through the problem and spend time on that. At least half an hour, okay? Before you submit, do not do a casual attempt like 10 minutes or 15 minutes. That would lead us to nowhere, I'm telling you. Okay, so please take time, okay? Fill the Canvas assignments, and I'll be giving you some more things to think about from this, whatever we learned today evening. Go through them, and we'll meet again on Wednesday, and then again of course, on Sunday. Okay? Any question?
No.
No. Anyone, any question, you can raise your hand. Okay. Okay, fine. So some of you want to have questions. Okay, you have pinged me. You can stay behind. Okay, others can drop. You can log off. Right.
Bye. Thank you.
Six or left. Okay. B. Devishri is there. Manu is there. Okay, go ahead. Who wants to go first? Devishri, Manu.
Manu
Uncle,
might take some time. Manu can go first.
yeah, Uncle, I just wanted to say about the Canvas. That was just, I didn't put much effort in this week. I had like Science on Bad States coming up, and we had like another club called BPA. We had states for that as well. So
Manu, let me tell you something, okay? And this is not a most comfortable discussion that I will have, okay? But I'll still tell you, okay? So look at the Science Olympiad will come, okay? And you have to take that seriously. I am all for it, okay? But when it comes to mathematics, okay, we cannot ignore the assignment. There's a reason for that, okay? the number of topics, okay, that we needed. If indeed you are serious about AMC, okay, man, I'm telling to all of you, not to you, do not think, but because two of you are there right now, I'm, it's for only two of you,